Okay, so let's begin with the formula for the area's triangle. But how do we get this formula? We don't call the definition, right? We begin with the formula. This is a basic formula for the triangle. If you have the base, this is the height, the area is going to be b times h. Now, how many of students know how do we get this formula, right? We do not define the area of the triangle. But if you know, let's try. If you know how to play puzzle, right? So what we do is we duplicate the triangle. Okay, we duplicate triangle and put on the top. So what you get is a parallelogram, right? What you get is a parallelogram. Now, how do you find the area of the parallelogram? If you can find the area of parallelogram, then divide by 2. But then you say, okay, I know the formula for area of parallelogram. This is a height, this is a base, and b times h, right? Divided by 2 gives the area of the triangle. But still, how do we find the area of the parallelogram? So you have to make it a triangle, a rectangle. You cut this corner, okay? You cut this corner and you move it over here. So this is a corner, okay? This is a triangle, and then you put it here. So what you get is a rectangle, right? Right. So that's the reason the area of the parallelogram is going to be b times h. The reason is if you cut the corner, move to here, you make a rectangle, and you do not change the area of that figure, right? So b times h is the height, right? B times h is going to be the area of the rectangle, and we know that, right, from last class. So divide by 2 is going to be the area of this area of the rectangle is going to be the area of this parallelogram, and then divide by 2, you get the area of the triangle. Okay, so that's how do we get the area of the triangle. Of course, the simplest formula is for the area of triangle is if the base is 5 and the height is 2 units, then the area is just half base times height, and which is 5 square units. Okay, and this can be taught. I can teach 2 second-grade students to do this problem. Okay, it's not necessarily you have to wait to the middle school, but we are not only just do this type of problems using, just use a formula directly. That's called the one-step problem, right? But we want to see a little bit more. Suppose I draw a triangle, right? And this is a 2, this is a 5. Then I draw another triangle, looks like that. It's also, it's going to be 2. Okay? My question is, do they have the same area? Right? This is a triangle, looks much larger, right? Right? But they have the same base. So without doing computation, you think the one shaded of the triangle is larger. Of course, the size is larger, so it's longer, okay? But does that mean it has more area, okay? If you have 2 pizzas like that, you probably, in my opinion, it will be same. Let's do the computation, right? Right? So the area for each of the triangle, by the definition, the area is just 5 times 2 times, 2 times 5 times 2 divided by 2. So still 5. Doesn't matter which one. It's really independent. They're all of the triangles, as long as they say same base, same height. That could be a different shape. They have the same area. Okay. So if you are given 2 pizzas, you have to make a choice, right? All you have to do is they look different. It's harder to see that, right? All you have to do is if they have the same base length, it's 5 inches. Then you look at the height. If the same height, okay, even one pizza is longer, and they're still the same size. Okay, same area. Okay, you're not going to get more. The 0, right? So this is an important fact. Okay, you can and then you can draw two line parallel lines like this. Okay, this is a two lines parallel. Okay, parallel means they always have same height. So the one in the middle is equal. Could be the equilateral triangle, right? So this is a base, and I'm going to say 4, right? Okay, and then the height. I also use let's say 3, right? Then you can move the point, this point P, back forward. Let's draw two triangles. So you can move this point all the way to the right, okay? Then you stretch the triangle, but with the base fixed. So the triangle is getting longer, but does not change the area, okay? So it's hard to imagine at the very beginning. I can move this point out of the universe, okay? 1 million kilometers away, even longer, okay? 1 year, 1 light year, for example, okay? But as long as these two lines are parallel, and then the distance between two lines of 3, and you're not going to change the area. But what you see is that this triangle become more, those two lines, two sides will almost collapse to one line, okay? But still, the area is going to be half of 4 times 3, which is 6 square units, okay? And you can draw a very long triangle. So remember, the area triangle only depends on the base and height. Does not depend on the shape of the triangle. It could be very long triangle. Okay, this is an important fact. Okay. Then I changed the problem a little bit because we not just want to use the formula directly, right? And I still have two lines parallel. Yeah, I say parallel. Okay, and I look at this. I find out this is a triangle. Okay, and the base is give me 4. Okay, so now this triangle assume that has areas that's so 4 cm, and this triangle has the area 4 cm square unit. Okay, then I have another triangle at different location. Okay, I can even give you extra data. Okay, so this is the triangle. I'm going to be here, right? That's a point P. Okay, so I can tell you from here to here is 10 square centimeters, 10 centimeters. So what is the area? Okay, what is the area of the triangle ABP? Okay, now this is called two-step problem. All right, the area of this triangle, I just told you, right? Because this triangle, these two lines are parallel that have the same height. So no matter where you put the P point, where's the location of P, you don't get the different areas. The triangle, they must have the same area, okay? So you even don't need to know the information like a 4 centimeter, 10 centimeters. It's not necessary, okay? It's not necessary because when you calculate the area, you use the same height. So the area, what you should do is, when you do the homework, don't just put 4 square centimeters, okay? Because I don't know how do you get that. What do you have to say? Complete the solution will be, you can say the area of the triangle ABP, okay, equals the area of the triangle ABC. Why they're equal? Because they have the same height. Since they have the same height, same height, and the same base. Okay, this is a complete solution. Okay, you needed to learn how to, no, you have to change the way to do the problem. Now, don't just focus on answer. I'm not going to ask you the answer. I already gave you the answer. If you ask your parents, where's the answer key? Yes, I give you the answer key. Maybe you don't, your parents probably keep the answer key from you. Okay, so you don't just give me the answers. You have to show me how do you solve the problem. Of course, you think it's the reason you came up with the 4 square centimeters because that's what you think. Because they have same height, same base. But you have to say clearly in the solution. A solution consists of all the steps plus the answer. Okay, not just the answer. That's the difference between answer and solution. Okay, but we give you the answer key just because we want to. You can check whether your idea is correct or whether all the computation is correct. Sometimes the idea is correct, but the computation is wrong, so you end up with the wrong answer. So that helps you to redo the problem. Okay, right? So sometimes information extra, you don't need it. This information. Okay, you don't need those information. And this is a 2-step problem. Yeah, kind of 2-step. You do not use the height. You do not use the base direct. Even you want to use the height, you probably can. Can you find the height of this triangle? You don't know? Can you find the height if you want? Yeah, if the height is h, right? If the height is h, you get the height. The reason is the area of the triangle ABC is going to be half of the base times height, which is 2h. But we already given this is a 4 square centimeters, so h is going to be 2 centimeters. Okay, if you want to find height, you can. Okay. Yes. Okay. The next one is a little bit tricky here. So I have a triangle. Actually, there are 2 triangles here. Okay, 2 triangles. Okay, and here's 2 centimeters. Here's 4 centimeters. Okay, I know this side is 4 square centimeters. My question is, what is the area of this triangle? A, B, C, D. So what is the area of the triangle ABD? Right? Right, so this is called 2-step problem. Right, everybody knows the formula for the area triangle, and technically you can use that formula to solve this problem. Okay, I already give you. See, look at those 2 triangles, right? The larger triangle is divided into 2 triangles, right? And I know the area, I know the base, right? 2 centimeters, 4 centimeters. I know the area of triangle on the right-hand side. I want to figure out the area of the triangle on the left-hand side. Now, what do you need? I want to calculate the area of the triangle on the left-hand side, right? You need the height, right? Can you get the height? Well, we just did it, right? So the height that share the same height as those 2 triangles. This is h. H is the height for both triangles, right? So if you find, yes, write down this, right? First of all, the area of triangle ABD, okay, is going to be half of the base times the height. So just I. So if you know the height, you can solve the problem. That's called 2-step problem. In advanced mathematics, we have to sometimes solve 3-step problem. Okay, 2-step problem. It's a step yeah, you have to solve that one first problem first before solve another problem. So you have to find h first. H is not given directly, right? So you use the right triangle, the triangle on the right hand side, to figure out the h. And we know that the triangle, the area of the triangle is the area of triangle ABC is going to be half of 4 times h, right? And that is going to be 2h, but we already know it's 4, so h is going to be 2. So once h is 2, then you can figure it out as the area of the triangle on the left-hand side, right? Left-hand side. So it's going to be 2, okay? All right, so yeah, just because you know height, base times height, and divide by 2 is 2. 2 square centimeters for the units in the answer. Okay.
你用这个。
Okay, so I'm going to ask you to do a similar problem. Okay. Yeah. So I'm going to show you. Let's see. Okay, so this is a right triangle. Okay, here's 2. This is 3. That's gonna be 2. Okay. Just do one more problem. So find the area of this shaded region, the shaded triangle. Yeah, this is A, B, C, D. Okay. So find the area triangle ADC. Come on. What is the area of this triangle? 5. Are you sure? ADC. The shaded triangle. Shaded. Well, this is the base is 2. The height is also 2. So the answer is 2. Right? Yeah, AB. Yeah, B is here. So now we see the right triangle. Right triangle is special. Let's recall the right triangle, okay? Some the basic formulas for the right triangle is called the Pythagorean theory. Okay, if you have this used there everywhere, let's say A and the B and the C. Okay, it's a right triangle. It is a right triangle if and only if A squared plus B squared equals C squared. Okay. So as you see that, now everybody knows this triangle, right? It's 3 and 4, and this side must be 5. Okay, 3 squared plus 4 squared and 5. But this is not always true like that. If you have a 4 and 5, right? What is the other side? Cannot be 6. It's not necessary. So then you have to use above formula if it's right triangle. Okay, here's 3 squared plus 4 squared equals 5 squared. So question is here, what is C, right? Right, then you have to use the Pythagorean theory to solve the problem. C square equals 4 square plus 5 square. So that is going to be 16 plus 25, which is 1 here, 41. So C is going to be square 41. It's a very bad number. It's an irrational number. Okay? Right? So here's a challenging problem. You have an equilateral triangle. Okay? Equilateral triangle. Both sides are all equal to 1. What is the area? This is also, again, it's a two-step problem because you're not given the height directly. You're not given the height directly, right? If you know the height, you can solve the problem. Question is, how do you find height? Okay? Height, right? You draw the line, it's height, right? So if you know the height, you can solve the problem, right? The area is going to be half of the base times height. So how do we find the height? Use the Pythagorean theory, okay? Because when you look at this triangle, right? This is a h. This is just 1/2 of this 1. So this is a right triangle. The three sides are related. So h squared plus 1/2 square equals 1 square. Then you solve for h, then you answer the question. So h squared is going to be 1 minus 1/2 square is a quarter. So simplify, you get 3/4. So how do you find h? Just take the square root of 3/4. But you can also write it like this. And square 4 is going to be 2. Okay, so that is the height. It's irrational number, that's okay. Then you put into the above formula, so the area is going to be half times h. So it's a square 3/4. Right? And the same idea, you can use it for isosceles triangle. Okay, for isosceles triangle. Let's look at the next problem. I'm going to ask you to do the next problem. Okay. It's going to be 12, 12, 10. Find the area of this triangle. Okay. It's also two-step problem. Can you find the height? Right? In geometry, right? How do you find it? Draw the line and just apply the Pythagorean theory to find the height. Okay. Let's see. So you draw the line. So equilateral triangles are divided into two equal sides. So you get the triangle. This side is 5, this side is 12. Here's h. Okay. Then h is the height, right? Then you apply the Pythagorean theory. So h squared plus 5 squared equals 12 squared. Then you get h squared plus 25 equals 144. So h squared equals 144 minus 25. And that is going to be 109. Right? Yeah, 109. So h is going to be square 109. then, right? 44 minus 25. Oh, wait a minute. So it's 19. 19, yes. Okay. Then the area is going to be half of the base times the height. So it's a 5 times square root of 119. So in many cases, you get radicals, okay? You're not get the integers, right? Now, if you recognize this is a right triangle, and that helps you to solve the problem. Sometimes the triangle is given in very bad position, like here's a 5, it's 12, and the 13. What is the area? See, this is a very, in general, it's harder to solve it. We don't have a formula yet. Okay, we're not giving a general form. So 3 sides uniquely determine the triangle. So of course, you should be able to find the area. So you are given this triangle. But first thing you have to check whether this is right triangle, right? So 5 square plus 12 square equals 25 plus 144 equals 169 equals 13 square. So what does that mean? This is a right triangle, okay? It is a right triangle. If a right triangle, you let it stand up, okay? So here's a 5, here's 12, here's 13. This is right triangle. Then you know the height, you know the base, right? So the area is going to be half times 5 times 12. And that is going to be, right, 30. Okay. So the triangle may be not marked like a right triangle, only given 3 sides. But there are some triangles, it's possible it's a right triangle. Okay. In this case, you can solve the problem. If you recognize that, you can find the area quickly. Yeah. Yeah, there are many tricks here, right? Now, if I give you this triangle, everybody knows this is the right triangle, right? So 3, 4, and the 5, right? Yeah, this must be right triangle. No problem. What I'm going to do is I draw the line because some students want to, for example, if you really want to, you are very curious about if I draw the line here, I get an H, right? This is the height to this side. Can you figure out the height? Okay, you can use knowledge you learned today to figure it out. The idea is, first of all, you know the area of the triangle, right? What is the area of the triangle? The area of the triangle is going to be what? This is a right triangle, right? It is a right triangle. It's a right triangle. So it's going to be half of 3 times 4, it's a 6. So once you know the area of the triangle, can you find H? Because the triangle you can rotate and put in different position. So the area of triangle can be also calculated as by this formula, right? The base times height. Then you get the identity, right? You get half of this can be 6, right? So then what? H is going to be 12 divided by 5. So it's fraction. Okay, when you go home, look at the notes first before you do the homework. Okay, so right triangle, if the three sides satisfy the Pythagorean theory, they're right triangles. Okay, you can always figure out the side. So here's a rectangle. Okay, this is a 3, and this is a 4. Okay, what I want to do is put the middle point. So this side is 2, 2. Okay. All right. So here's 1. Okay, this is a 2. And let's find out the A, B, and C. Yeah. Find the A, B, C. Well, just use a Pythagorean theory, right? Yeah, find the A and the B and the C.
It's right.
It's good. You following? Huh?
It's a right triangle.
Okay. All right. So this is a rectangle, right? This is a rectangle. I want to find the 3 sides of 3 lengths, right? A and B and C. So you apply, just practice using Pythagorean theory, right? The first one, let's find A. A squared equals 2 squared plus 3 squared, right? 4 plus 9, and that is going to be 13. So what is A? Square of 13. Okay? And then how to find the B? B squared is going to be 1 squared plus 2 squared, 1 plus 4. No, that's 2 here, 2. Okay? Because this is a 2, here's a 1. So yes, 2 square, 2 square. So it's going to be 8. So B is going to be square of 8. So you get very strange triangle inside. C square is going to be, this side is a 4, right? And that's 1. So it's 1 square plus 4 square. It's 1 plus 16, 17. So C is the square of 17. Okay, so you got 3 sides of the triangle, right? Applying the Pythagorean theory. Okay, no problem. So there was a similar problem on the math competition. So they wanted to find out the area of the triangle this. Okay, so the area of the triangle. Now, if you use how do you find the area of the triangle? You want to say, I don't know the height. And this is not the right triangle. Right? So stop. Right? So the idea we are using here is called the subtraction method. Yes, you cannot find the area of the triangle directly, but you already have the knowledge to find the area of this triangle. How? Use the subtraction method. Step 1, you find the area of the rectangle. Step 2, all the 3 triangles around that are right triangle, right? So it's very easy to find out. Then you just subtract the 3 triangles, the right triangles from the rectangle. Then you get the result. Just called subtraction. Yeah. So if you just focus on the one you're given, then probably you cannot figure it out. Yeah, you cannot find the area. But if you look at surrounding area, maybe it's easy to determine the triangles around that. Okay, so this is a kind of most tricky problems. Let's finish it first, then we move on. Okay, so the area of what is the area of shaded? Okay, and you have to use a subtraction method. So the area of the triangle, a rectangle is 3 times 4 because the length is 4, width is 3. Then you minus the area on the right side. Right side is the base is 2, the height is 3. Then you minus the area of the other triangle. It's going to be 2, 2, right? Then minus the area of the one at the bottom. So then, if I told you how to do it, it's not that difficult. So it's 12 minus 3 minus 2 minus 2, right? Total is going to be, right, 5. Okay, so the area of shaded region is 5. Yes, 5. Just use the subtraction. Okay, use subtraction method. So okay, here's a question again. I have this is a base. It's 2. Okay. So what I'm going to do is here's A, B, C, D. My question is, I choose a point E. E is arbitrary. I choose 2 points P and Q, also arbitrary. I'm going to connect this point. Okay. So I shadow it. Okay. My question is, can we determine the area of shaded region? Can we determine the area of the shaded region? Why? If the answer is yes. The shaded region consists of 2 triangles. Okay, and where E, P, Q, okay, are not fixed. They are just moving, shaking. Okay. Yeah, this is a rectangle. Okay, first of all, it's a rectangle. Okay, it is a rectangle. So what they do is there's a point on the top E, it's moving. Okay, left, right, shaking. Okay, and then there's 2 points P and Q also change locations. My question is, when E, P, Q are changing, okay, does the area changing? I know the shape of this region is changing, right? It's changing. Okay, when P, Q, E, the locations are changed, and then the shaded region is changed. But does the area, questions, does the area change? If not changed, what is the area? If it's changed, can you show me 2 examples? There are different areas. Hmm? Yeah, E is on the top, yeah. The dot, yeah. So the 3 points, okay. Okay, Vincia, do you have any ideas? Some people are very quiet. Richardson. Erica. Erica, are you there? Yeah. So let's see. Okay, any of you give me the answer? Okay. Yeah, this is kind of like uncertainty problems, about problems about uncertainty. But if you think it's a certain, the answer is certain, then you have to give me the argument. Okay. The region consists of 2 triangles, right? But what is not changed is the height of those 2 triangles. Do you agree? Okay, what is changed is the base. So let's see. Here's X, this is Y, right? So I know the area is going to be half of the first triangle is X times the height is 2, right? Second one is Y times 2. So after simplifying, I just X plus Y, right? That is the area of the 2 triangles. So if I cannot determine the sum X plus Y, then I say that the area cannot be determined. Okay? Because X and Y changing, right? Do you agree? X and Y change because when the point E changes, when the point P and Q changes, it does not show up in the area formula because the height is fixed. Height is always 2. So I don't see, this formula is not sensitive to the location of the area, right? The expression for the areas is not sensitive to the location point P and Q. But clearly, right now, it depends on X and Y. So if you change X and Y, right? If X changes, but the problem is that, yeah, X and Y individual values can be changed. What is the sum? The sum is not changed, right? Because that gives the length of the rectangle. So this is always equal to 4. Look, right? Add them together is the total length from between, right? Between A and B. So that's always true. Done. So this is a proof, okay? So it's always equal to 4. Okay, it doesn't matter where is the location of, where's the location, okay? All right, let me ask you to do another problem. Here's a rectangle, okay, this side is 3. And here's a point. Yeah, this is a, yeah, here's a 1 and the 1. Right? Yeah, this is actually the square. Okay, find the area of the shaded triangle. Right? Hello? Anyone? My hint is to use the subtraction method. Can you do it quickly? All the region around the triangle are very good, right? You got right triangles. We get trapezoid, but if you don't know the area formula for trapezoid, you probably have to draw the addition line like that because this is a poach. This is rectangle. The other one is the right triangle, right? Okay. Yeah, if you don't want to use the area formula for the trapezoid, yeah, I'm going to talk about trapezoid. Trapezoid is a part of the triangle topic here. So you see, so you just needed to focus on this rectangle. You don't need to worry about the rest part. Okay, so the area is going to be the rectangle, area of the rectangle, which is 2 times 3. Okay, 2 times 3, the height is 3, right? 2 times 3 minus the area on the top left, top right, 1. This is going to be 2, right? So it's 2 times 2 minus the triangle at the bottom, right? And the minus area of the triangle, it's also 1 times 3. Okay, okay, so let's simplify. 6, 2, 1/2, 3 over 2. So actually it's going to be 2. 6 minus 2 minus 2. That's going to be 2. You cannot easily find the height of the triangle. If you really want to, it's easy. You can find the length of each side. That's not, you cannot use them to find the area. Okay, you cannot use them to find the area. So let's think about the trapezoid. Okay, what's the definition of trapezoid? Trapezoid, if these 2 lines are parallel, right? This is called trapezoid. So trapezoid is just part of the triangle, right? If you extend it, right, you get triangle. Can you derive the formula for trapezoid if you never heard about trapezoid? Right? If this top is B and A, and the height is H. Just do it the same way like a triangle. What you do is you duplicate the trapezoid, and then you put it here. Okay, double. If this is A, that will be A. This is B, that is B. Right? And what you got? You get a parallelogram. So the area of the area of this parallelogram, if you know the height, is going to be A plus B times H, right? Yeah, the base length times height. So the area of the trapezoid will be half of that. It is very similar to the area formula for the triangle. Okay. Okay. So now, if you have here's 3, right? Here's 5. If you know the height, it's 3. Then you know the area, because this is going to be 3 times plus 5 times 3, right? And that is going to be 12. Okay, no problem. Right? We just find that's just direct the formula. You can, as long as you know the formula, you know how to find the area. You're given all the information you need. Right? The height, up, lower, the base. Right? But sometimes the height is not given. Okay, just like other problems. So this is a trapezoid, first of all. And here's 3, here's a 5. I draw the triangle. Okay. I know the area of this side. This is A and the B and the C and the D. So I know the area of this is going to be area of this triangle ABC is going to be 6 square units. What is the area of the other triangle? BCD. Okay. Right. Right. If I use a centimeters, 5 centimeter, this will be square centimeter square. I want to find the area of that region. It's also two-step problem, right? The first one, the above one, yeah, two-step problem. We are not given the height of the triangle. That's it. Questions, can you find it? Right, that's my hint. Anyone get an answer? Are you still working on that? Can you tell me the answer? No? And so this is the height, right? But this height is also the height of the upper triangle. So the area of the triangle ABC is obtained by half of the base is 3, times the height, right? Because the distance between two parallel lines is the height for both triangles. That's the key point, right? Then for the upper triangle, right? AB is the base 3, right? The height is h, and this is supposed to be 6. So can you find out the h? Yes, h is gonna be 2, right? No, h is gonna be 4. Okay, h is gonna be 4. 3 times 4 divided by 2, 6. So once you get the h, then you solve the problem. That's it, right? So the area of the triangle BCD is gonna be half of the base, which is 5, times 4, it's gonna be 10. Right, that's it, right? It's gonna be 10. So that's how do we, this is how do we find out the area of the trapezoid, right? Okay, let's have a quick review on the problem. Okay, we have a triangle, right? This side is 8, the other side is 63, and this side is 65. Okay. What is the area of the triangle? Now, in general, it's harder to find the area, okay? If you're given 3 sides of triangle. But we are lucky here. We check, you can check a square plus 63 square. That's the first thing you can try. Is it going to be 65 square now? Yeah. Let's look at the calculator. Okay. This is a, yeah, let's use a cake. So this is 64, right? 63 times 63. Okay. 65 times 65. 4225. Okay.
Who's doing that?
I don't know who is doing that. All right, so you add them together. I'm not sure. This is the 6354. Actually, it's not a triangle, okay? So this is another right triangle. Then what? They're not equal, okay? They're not equal. So you cannot solve the problem, right? Hmm? Yeah. So you cannot solve the problem, but does not mean it's the end of the story. There's this guy called Huron. Okay. He said, well, if the 3 sides are all given, the triangle is uniquely determined, I'm sure be able to find the area, right? So he did it. He discovered the formula. I just give you the formula right now. He said the area is going to be square root of S, S minus A, S minus B, S minus C, where S is half of the parameter. Okay, so he's the first person discover that. Then he used the 3 sides. He can always get the area as long as the 3 sides are given. Okay, so you can use that to double check the formula. The triangle like this. Suppose you don't know this is a right triangle, right? How to find the area? So area is going to be what is S? S is going to be add all together. 8, 5 plus 3 plus 4 divided by 2, 8. So it's a 6. So 6, and the 6 minus 3, 6 minus 4, 6 minus 5. It's magic, right? It's going to be 6 times 3 times 2, and that's 6. Okay? And then you can check his formula using all these right triangles, and they all works. But the proof is not easy, okay? If someone can figure out the proof, let me know. Maybe you can find on the internet. If you're really curious, okay? Maybe you can see the proof how it's working. But this is a proof. This is a good formula to use sometimes, okay? I'm not going to go through the details. Let's stop here. Okay, remember, we have to learn how to use, we have to solve the problems, 2-step problems, okay?